So here I am back in my virtual machine with the Cloudera Hadoop implementation. And I'm using the Hue browser again because it just makes things simple. If you want to set this up, you will have to load the samples, and I showed how to do that in a previous movie. And then you'll get all the various samples. Now, you might remember from the Hive section that we ran through the Hive sample queries here. And if you forget with all these different libraries, you can just click right here in the query editors, and it actually shows you. You'll probably remember the pig, though, because it looks like a little pig. So I'm going to go ahead and just look at the pig example that we have here, and let's run through that. So the first thing that we're going to do is we're going to register a piggy bank jar file. So you might remember from the word count section that a jar file is a compiled Java file. So what this pig workflow is doing is it's going to combine a jar file or a Java MapReduce process with a pig process, which is really common in the real world. So it's not just a pig process, it's both. So here we've got a data variable, and we're using the pig keyword load, and we're going to load some examples, Midsummer Night's Dream, it looks like here, as a character array. And then we have an uppercase variable, and we're going to for each into that data, and we're going to generate, as is common, some output that we're going to uppercase all the text. And then we're going to store that output into our output variable. So let's go ahead and run this. And we need to specify where this output variable is. I'm just going to go ahead and put test output, lin. And now this is running. And just like with the Hive example, the underlying implementation is going to be MapReduce. So if we wanted to, we could go over to the job browser and we could look at the status of the job. Now, it's very common that pig jobs are chained together, or like this one, they have a jar file so that they actually can be quite long running. It's not uncommon to have pig jobs actually run for minutes, hours, or even overnight for really huge processing. So part of working with the Hadoop ecosystem is to set some monitoring on the jobs to see if they time out, especially when you first run them. Here you can see we've got a 1 because we have the job is started. And so this job is going to take a couple of minutes, and then we'll take a look at the output. Oh, there it's going. Okay, so let's just read this output. So again, we're accessing the information, and we're seeing the deprecated messages again, just like we did with Hive. Do you remember why that is? It's because there's two different versions of the MapReduce API, and we really are in the Hadoop ecosystem still in the process of transferring from MapReduce 1 to MapReduce 2. So you'll often see that. When you see deprecated, it's telling you that there's some part of this that is using MapReduce 1, which is not necessarily a bad thing, but it is something to look for if you've got bottlenecks, because as the ecosystem progresses, of course, the libraries become more optimized. So one of the things that I found in production is sometimes if you change out the deprecated portions with the new MapReduce algorithm, which you would do by using more modern functions in the pig example, you can get faster performance. And there we can see this is running. Let's just go down, take a look. So we have multiple jobs. See, like here, it's actually telling me in this line that's using compression, and the MapRed output compress is deprecated. We should use MapReduce. This is actually quite important in big-sized jobs because, of course, the efficiency of the compression algorithm can really impact the amount of time it takes to run the job. So I know it might seem kind of mundane to read these log files, but it is a big tip when you're trying to debug and make these processes run faster. I'm going to scroll down some more and read more of this. Again, remember from the Hive example that we are running in pseudo-distributed mode here, which means that we do not actually have multiple data nodes. So you won't see any splits because we have only one HDFS data node. And this is something that you can get away with when you're testing big jobs, but unlike Hive, you more often want to run in actual distributed mode when you're testing because you want to understand how the splits are running and make some sort of prediction about how this is going to work in a production environment. Because just sort of as a general concept, pig scripts and jobs are used to process larger amounts of data. You might remember when we were talking about Hive, we talked about partitioning or splitting or running Hive queries on subsets of data, just like you do in a relational database. Whereas pig is more analogous to, like I said, SSIS and SQL Server, where you're going to process all of the data. So paying attention to performance becomes more important in the pig world, in my experience. So we're going to scroll down here, and here we're doing our upper casing. So you can actually see each task when it occurs. Now, one of the things, again, that I've used in production situations is there are log readers that can help you to do things, because basically you're going to diff the time here to find out how long these tasks took to figure out where the bottlenecks are, and they'll actually do it for you. So again, here we can see we're launching into the map task and the reduce task, and then we've got statistics as well. You might remember that from the Hive movies, that you can optimize on statistics. That's less of a common activity in pig scripts because you're not doing individual queries, rather you're doing processing on everything. And here we have success. So this would be output into that new folder, because you remember that HDFS files are immutable. So we've made changes here. And if we were to go into that new folder, we would see the successful output, which is uppercased. And here's the test output. And here we see the success message. And we see the output has all been uppercased.